welcome to another lesson. This afternoon we want to look at number theory. And before we actually get into number theory, I did some reading and I read that our minds can be seen as little gardens. And it is all up to you what you want to plant in the garden. Whatever you plant with, something is going to grow. And it's all up to you what you want to grow in the garden. So this afternoon, I want us to plant seeds on number theory. And in number theory, we'll be looking at approximation and estimation. Now, when we look at the word estimation, we know the root word for estimation is estimate. And when we make an estimate of something, we're making or we're giving a rough value of what the thing actually is. For example, you want to build a house. Your parents want to build a house. Before they actually get into building the house, they ask a carpenter or a contractor to give them an estimate, roughly a rough figure of how much it's going to cost them to build the house. Now here in example 1, I want to find the estimate of 490 multiplied by 10. Now I know that 490 is close to 500. And I take my 500 and I multiply by 10, and my estimate for 490 multiplied by 10 would be 5,000. But my exact value when I multiply 490 by 10 would be 4,900. And when we compare the exact value with the estimated value, we notice that the estimated value is doesn't have a great difference from the exact value. It's somewhere in the vicinity of the exact value. Now let us take a second example. We have 96 is being multiplied by 8. And then we're going to add 700. Now we look at 96, and we know it's close to which number? 100. So we round 96 off to the nearest 100, and we multiply by 8. Then we're going to add our 700. 100 multiplied by 8. What would that give us, Renee? 800. When we add 800 to 700, what would we get, Keisha? 1,500. The exact value when 96 is multiplied by 8 and then 700 is added would be 1,468. And if we look, 1,500 is not very far away from 1,468. So an estimate is a rough value. It's not exact. It's somewhere about what the exact value is. Now we're going to use decimal places and significant figures to understand estimation and approximation much more. So we start off with decimal places. Now how do we figure out decimal places, or how can we tell how many decimal places are in a number? First, we identify the decimal point. Then we look for how many figures or numbers follow the decimal point. In the first number, 1.6, one number follows the decimal point. So this number is a 1 decimal place number. We say 1 DP for short. In the second number, 11.67, How many numbers follow the decimal point?
2.
So we call this number a 2DP number, or we say this number has 2 decimal places. 1, 2, and they come after the point. And the third number, 11.679. Jonathan, how many decimal places are in this number?
3 decimal places.
3 decimal places. 1, 2, 3. After the decimal point, that's where we check. Now there are some conditions that we need to know when we want to approximate to a number of decimal places. Now our first number is 247.746, and we want to take this number and rewrite it with 1 decimal place. So we count. As it is, it has 1, 2, 3. 1 decimal place ends here. After this line that I've drawn is a 4. When you have numbers 0, 1, 2, 3, and 4, nothing is added to the number in front of the line. Or we can say we add a 0. So to 1 decimal place, this number becomes 247.7. 1 number follows the decimal point now. Good. So after we have operated here with 247.746, which is 3dp, and taken it to 1dp, the number now becomes 247.7. 1 number follows the decimal point. So we say it's a 1dp number. The second one, 247.792. Here we want to take it to 2 dps. So we count 1, 2. After the decimal point, after the line that I've drawn, it's a 2. And when this 2 falls into a category like this, what do we do to the number in front of the line?
Add 0.
We add 0. So to 2dp, 247.792 becomes 247.79. Now in the third one, we have 247.79254, and we want to take it to 3dp. 1, 2, 3. We draw a line. Now if you notice, after the line, there's a 5. Do you notice the 5 in this category?
No.
No. The 5 belongs to another category. So here we would have 5, 6, 7, 8, and 9. And if the number after the line falls into this category, we add 1 to the number in front of the line. So if we add 1 to 2, the 2 becomes a 3. So our answer is 247.793. Let's continue. We have number 4, 247.79354. And we want to take it to 3 dps. Where should I draw my line? After which number?
The 3.
After the 3. Why do we draw it after the 3?
In the 3rd decimal place.
Because 3 indicates where 3 decimal places would stop. So I draw my line. Now what you are going to do for me, you're going to quickly copy this off and round it off to 3 decimal places. became a 4 because after the line appears a 5. And the 5 falls in the category 5 to 9. And anytime we have one of those numbers falling after the line, we add 1 to the number that precedes the line. Okay? So 3 plus 1 becomes 4. Now let's check if we see if we have 3 DPs. 1, 2, 3. Remember, we're starting from after the point. 1, 2, 3. Now I have a nice one here. Really, really interesting. We want this one to 1 DP. So we're going to stop there. Before the line, it's a 9. After the line, there's an 8. Should we add 1 or should we add 0? What should we add to the 9? Should we add a 1 or should we add a 0?
1.
We should add a 1. Now let's see what happens. So we're going to add 1 to the 9 because the 8 is in the 5, 6, 7, 8, 9 category. Now when we add the 1 to the 9 becomes a 10. And we can't write 10 there. We can't write 10 there because that column is only for one figure, one numeral. So what we do, we leave the 0 here in the 10th column and we take the 1 across to the 1's column. So we end up with 248. Some people would put 0.0. But whether the 0 is there or not, the value is the same. So you might see in your examination a problem like this. And they say, take it to 1 DP. And you're looking at it and you end up at 248. And you're saying to yourself, but that's not 1 DP. That's only a trick. Leave your answer as that. You know you did the correct thing. Hold true to what you were taught. Okay? Good. Now that was all about approximating to a number of decimal places. And remember the key, you start from the decimal point and you move back. You count. How many you find, that's the number of decimal places in it. Now let us look at significant figures. We can approximate to a number of decimal places, or we can approximate to a number of significant figures. Now remember, mathematics is a subject where you have to be very, very observant. You must observe patterns, and then we can make generalizations. Now let us look here. 8, 80, 800. All we see is this dominant 8. One number that has value there. In the other instances here, 0 is basically holding place. The first, second, and third, all three of them contains one significant figure. And I'm going to write the shortened form, SF, one significant figure. Not because we see these zeros at the back, we count, well, this is 2 and this is 3. No. In these cases, only the 8 is significant. The 0 holds place. Now let us look at the second, the third, the fourth, and the fifth. In the fourth, we have 890. In the fifth, we have 8900. Again, holding place, holding place. In these two, we have two significant figures. Only the 8 and the 9 are significant. The zeros are placeholders. So this is when the 0 falls after. Now let's look at these. The zeros are at the back here. The zeros are in front here. 0.62, 0.062, 0.0062, 0.00062. You see the zeros again? So whether they are at the back or they are in front, again here they are only placeholders. They are not significant. The only numbers that are significant here would be the 2 and the 6. So all 4 of these are 2 significant figures. All 4 of them. So we see them at the back. We see the zeros in front. However, what happens when they appear somewhere in between the figures? For example, we have 102, 1,002, 10,002. Now they become significant. So here we have 3 significant figures, 4 significant figures, and this one would be 5 significant figures. Here we have 5 significant figures. And these were all wholes. And the same thing happened when we go across there. So here again, how much would we have here? How many significant figures here? 3,
4,
and
5.
so we have 3 significant figures, 4 significant figures, 5 significant figures. There are no zeros here. So as soon as you look at it, each numeral here is a significant figure. Miracle, how many significant figures are here? 3 significant figures. Renee, how many significant figures are here? 5 significant figures. What we need to be careful with is when there is a 0. If the 0 falls somewhere in between, as it is here, it's significant. You have got to count it. If it comes at the back, 80, 90, 1800, the zeros own the whole place. 0.003, they own the whole place. Good. Now here we want to round off, or we're going to write correct to the stated number of significant figures. Now remember when we were approximating to decimal places where we had 5 and up, we add 1, 4 to 0, we add nothing, right? Well, the same thing we bring across to significant figures. The first one has 1, 2, 3, 4, 5 significant figures. And we want to write this number correct to 4. 1, 2, 3, 4. After the line, we have a 6. So, what the 6 tells us to add a 1 or a 0? A 1. So, we're going to add 1 to the 3. And here we would have 27.94. And that would be the 4 significant figures. Now, let us look carefully at the second example. 1,705. 1,705. We want to approximate this number correct to 3 significant figures. But before we go there, remember an approximation is a rough value. Somewhere thereabout. It's not very far away. So if we have 1,705, when we finish approximating to 3 significant figures, we can have 1 or 14 or 17 or 170. It has to be somewhere around 1,705. So let's go. 1, 2, 3. After the line, we have a 5. It's a 5 and up category. So we know we have to add 1. So when we add 1 to 0, 0 becomes 1. So we have 171. Should we stop there? is 1,705 anywhere close to 107 to 1? No. So I want any one of the four of you to tell me, what should I do? Where?
To the end of the number.
We add a 0 after that one there. It's not significant, it's just holding place, and it's keeping 1,710 in the vicinity of 1,705. Okay? Because remember, when they're at the back, they're not significant. Only when they're somewhere in the middle. Good? So, my third example is to you. 4,379. And I want you to take that to two significant figures. Yes, Merkel, I'll start with you. Where did you draw the line?
After the 3.
After the 3. What falls after the line?
7.
What does the 7 tell you?
The 7 tells you that you have to add a 1 to the 3.
7 tells you have to add a 1 to the 3. So if I add a 1 to the 3 becomes 4. So I'd have 4 here. But then we see a vast difference between 4,379 and 44. So how do we take it to somewhere around there? We add zeros. How many zeros?
2.
We add 2 zeros. And when we look, we know that 4,400 is somewhere around 4,379. Now today we are looking at how we approximate and how we estimate decimal numbers and significant figures. Now, if we want to know how many decimal numbers are in a number, we look at the point and then we count how many numbers follow the point. And that is why when we can say this is a 3DP number or this is a 5DP number, with DP meaning decimal place. Now, when we're rounding off and we stop at some point, if we find that the number after the line we've drawn is a 5, a 6, a 7, an 8, or a 9, we say we round up, or we add 1 to the number in front of the line. If the number after the line is a 4, a 3, a 2, a 1, or a 0, we don't add anything, or we add a 0, which is nothing. Okay? Now, when we go across the significant figures, we have got to take caution. If the zeros fall at the back, they take up place. If they come in front, they take up place. But when they begin to position themselves in between the figures, we know they become important, significant, they count then. Okay? And the same 5 and up, 4 and down apply to significant figures. Now, America, you're going to tell me what you value the most in today's lesson.
I value approximating to significant figures.
You like significant figures more. Okay. Now, what makes it much more interesting than decimal places?
For one, the zeros, the quotient of the zeros.
Okay. Whereas in decimal places, the 0, you don't have to be that cautious about it. Good. Now let us recap quickly. Here, look here. Lesson 7, number theory, estimation and approximations. In this lesson, we will demonstrate an understanding of estimation and approximate numbers making use of decimal places and significant figures. Here are some key points. An estimate is a rough calculation which, if sensibly done, will give us an approximate answer. The result of a computation can be expressed as an approximation by using 1. A fixed number of decimal places, or 2. A fixed number of significant figures. Example 1. Find an estimate of 448 multiplied by 10. Solution. We could estimate 448 by 10 as 400 by 10 equals 4,000. The exact value is 4,480. Example 2. Estimate the value of 98 multiplied by 7 plus 500. Solution. We could estimate 98 multiplied by 7 plus 100 as 100 by 7 plus 500. That is equal to 1200. The exact value is 1186. Example 3. If a half tub of ice cream can be shared among 8 to 10 children, how many such tubs of ice cream can a teacher purchase to cater for a class of 35 students? Solution. Since there are 35 students in the class and approximately 9 can be served with 1 tub of ice cream, we can buy 4 tubs of ice cream for 35 students. The number of figures that follow the decimal point give the number of decimal places. 3.8 has 1 decimal place. 33.37 has 2 decimal places. 38.376 has 3 decimal places. Example 3. Express 121.746 correct to 1 decimal place. Solution. Write 121.7 and look at the next digit to the right, which is 4. Since 4 is less than 5, the answer is 121.7. Example 4. Express 121.746 correct to 2 decimal places. Solution. Write 121.74 and look at the next digit to the right, which is 6. Since 6 is greater than 5, then the answer is 121.75. Example 5. Express 121.7465 correct to 3 decimal places. Solution. Write 121.746 and look at the next digit to the right, which is 5. Since 6 is an even number, the answer is 121.746. Example 6. C. Express 121.7435 correct to 3 decimal places. Solution. Write 121.743 and look at the next digit to the right, which is 5. The number is 121.744. Another way of approximating a number is by using significant figures. 80 is equal to 80 correct to 1 significant figure. 800 is equal to 800 correct to 1 significant figure. 89,000 is equal to 89,000 correct to 2 significant figures. 0.34 is equal to 0.34 correct to 2 significant figures. 0.00034 is equal to 0.00034 correct to 2 significant figures. When zeros come between numbers, they are counted as significant figures. 7.072 is approximated to 7.07, correct to 3 significant figures. 8,001 is equal to 8,001, correct to 4 significant figures. Is the symbol for approximation. Example 7. The number 8.3875 correct to three significant figures is A. 83.9, B. 83.8, C. 8.39, D. 8.38. Key C. Summary. An estimate is a rough calculation which gives an approximate answer. It's the symbol for approximation. If the zeros come at the end or at the beginning of a number, we do not count them as significant figures. They are placeholders. Problems for today. Page 12, exercise 2E, questions 4A and B. Page 13, exercise 2F, questions 16, 18, 22, and 24. Page 14, exercise 2G, questions 30, 34, 36, and 46. Mathematics for Secondary Schools in Guyana, Book 3. Solution for the problems given in the last lesson. Page 10, exercise 2D. Evaluate. Number 2, 4.076 plus 1.028 divided by 0.016 is equal to 5.104 divided by 0.016, and that is equal to 319. 4. 12.72 multiplied by 5 divided by 0.106 equals 63.6 divided by 0.106. That is equal to 600. Solution for the problems given in the last lesson continues. Evaluate. 8. 0.01656 divided by 0.018 multiplied by 4.6 equals 0.01656 divided by 0.0828 equals 0.2. 10. 3.6 multiplied by 1.5 divided by 0.90 multiplied by 16 is equal to 5.4 divided by 14.4 is equal to 0.375. Now I know that when you leave here, you're going to go back to your classrooms and you're going to tell everyone in your class how important 0 is. When it's in front, when it's in the back, and when it appears somewhere in the middle. And remember, 5, 6, 7, 8, and 9, what you do?
Add 1 to the number.
And if it's 4, 3, 2, or 1,
Add 0 to
we add 0 or we add nothing. Now go have fun, rounding up or rounding down.